Yeah, well, hello guys, we're back. We are back with the video of today. Today we're going to divide into times. We're going to do a stream now for these questions on matter, elements, pure substance, etc. It's a few marks in the exam, and then we're going to do another question on a change in phase. We're going to be speaking about heating curve, cooling curve, etc. So it's a quite good stream. I was looking for different question papers, and I found that the best one, from my point of view, the one that may have the marks more like your exams, is the one in KZN, the one that gave you a long time ago, but we never went through the question paper. So let's do that one, and then we're going to start with question 2, guys, which is at the front. All right. So this question says 4 different substances W, X, Y, and Z are represented in the table below. We're going to go, remember, we're going to move a little bit more than just a question. We're going to explain a little bit more about that one, okay? So that is important to notice here. We're going to go a little bit more, not just doing the example or the question, right? So now the question gave you 4 different substances, and they ask you questions about the substance starting from elements and compounds. So let's have a look to this one and think if and see if you get clarity on whatever is going on here. First of all, let's divide matter, and this one is a grade A topic. So substances can be divided in 2 main groups, guys. Those are pure substances and mixtures. Everything can be divided in those 2 main groups, pure substances and mixtures. Now, pure substances, what is a pure substance? Pure substance is the one that cannot be divided, by physical means. It cannot be divided by physical means. For instance, you cannot use evaporation or filtration to separate. All right. If it's a pure substance, you cannot use any of those to separate the pure substances. Now, pure substance, furthermore, can be divided into groups: elements and compounds. All right. Mixtures, there are other types of mixture, but we're not going to mention that one. It's not part of the work. We're going to leave it there. They can be, remember, homogeneous, or they can also be heterogeneous. For us, we're going to leave it by mixtures, all right? But they can be separated by physical means. In other words, if you have a mixture and you want to separate it, you may use let me just look at this one here, guys. You may use evaporation, you may use filtration, etc. to separate mixtures. All right. So these substances, for instance, are not bonded. That is the most important part there. Those substances are not bonded. Okay, and therefore they can be separated using physical means. Okay. So we still didn't answer the question. I just trying to summarize a little bit, because this one could be asked in the exam. So going back, substances or matter can be divided into pure substances as well as mixtures. Pure substances cannot be separated by any physical means. In other words, you cannot take, if it's a pure substance, you cannot get and sort it with your hands. Mixtures, they can be separated by physical means, but they are not bonded. That is why they can actually be separated. Pure substance can be divided furthermore into elements and compounds. Now, why element? What is an element? Elements are pure substances made of the same type of atoms. Same type of atoms. That is what we call an element. And compounds is a combination or let me just maybe enlarge a little bit for you guys. I know you like it a little bit larger. 2 or more Elements bonded. They must be bonded. All this one is obvious for the question we're going to answer just now. This is like a small summary. All right, so I'm going to go back. Substances can either be separated into pure substance or mixtures, right? Pure substance, they cannot be separated by physical means, and that is the definition. You have to memorize that definition. Pure substance, right? They cannot be separated by physical means. Mixtures, they can be separated by physical means. Pure substance, furthermore, can be divided into elements and compounds. Elements are pure substance that are made of the same type of atoms. For example, guys, H2, for example, O2, those are elements. They are molecules of the same type of atoms. All right. Compound is a combination of two or more elements, and they are bonded. This is an important word here. They are bonded. All right. So, for example, of this one, H2O and NaCl. Those are examples of compounds, which are pure substances. Now, if we go back to the question, and I have to go now to this part here, the question says, is X an element or compound? Now, in this question, they give you a map here to identify between different atoms. Remember, you don't have colors. So the ideal is to use colors, but we don't have colors in the exam. It's black and white. So what you need to know, all these are atoms. All those are atoms, all of them. And they give you an idea that they are different because they are different atoms. All right, so now we are going to look for, let's identify all of them. What do you see here? You see three atoms that are the same type of atoms. In other words, they are lithium, and one atom in the middle, which is different, and it's called nitrogen. They are bonded. Therefore, guys, this one is a compound. Let's write it here. That is a compound. Let's identify all of them. This one. You see atoms of the same type, which in this case is hydrogen. They are bonded, but there is one atom of hydrogen bonded to another atom of hydrogen. All right. So this is element. This is, in other words, for instance, H2, because there are two atoms of hydrogen. All right. If we go to Y, now we have two of the same, but what is that? We have three atoms of the same, which is hydrogen, right? And we have one atom of nitrogen. So this is two molecules of a substance which is a compound. This one is a compound. They are combined. We have two compounds of the same type in this case. Combination of three atoms with another one, and they are bonded. How do I know they are bonded? Because they are attached to each other there. They are attached to each other, guys. You see? So that is why they are a compound. If we go to Z, now we have different types of molecules, different type of element, but they are not bonded. So this is the combination of element. So this one is a mixture. And then we, in other words, identify all of them. If we move a little bit further, this one here is going to be, the lines one is nitrogen with hydrogen is NH3. One nitrogen and three hydrogen. If we go here, then this one, for example, is N2. This one here is oxygen, so it's O2. This one here is hydrogen, in other words, is H2. So this one is a mixture of gases. All right, so now, before we move on, I want to know if that is clear. before we move on. I want to know if that is clear, guys. That is in terms of the first part of the question. And we answer couple of it. If we go back to the question, my lovely, we can see that we answer, for instance, is substance X an element? We already know what substance X it is. It is an element. Give a reason for your answer. You are coming back to this part here because it's made of the same type of atoms. All right, it's a pure substance made of the same type of atom. That will answer that one. If we move on here, write down the letter of the substance that represent a mixture. We already answer because we answer all of them. The mixture is going to be Z. It's a mixture of gases and it's a homogeneous mixture because you won't be able to see the different gases there. All right. And we move to the next question. I have to be up and down. You know that. Write down the compound name of substance Y. Now we're going to substance Y. Let me just see if it was clear that a question. Okay, you have to tell me if you understand, guys, or you don't. So we go to substance Y. Substance Y is NH3. Guys, there is a law for this one. Every time there is a combination of one nitrogen with 3 hydrogen, that is ammonia. Nothing to say. You have to learn this one. Look here. We did write the formula because with the picture, maybe you get confused. This one is ammonia. Hey, what I was going to write there, my lovely, I'm sorry, I don't know what I was going to write there. Let me just erase up that one, sorry. Ammonia is ammonia. Is ammonia. The symbol NH3. It is a compound. It is an important compound that you're going to use all the time. All right. So let's go to the next part of the question. If there is not any question from you, my lovely. The next part of the question, I have to move this one a little bit down. There we go. The picture, I have it at the front. Write the common name of substance Y and draw the Lewis diagram for substance X. Now, the Lewis diagram is very important. All right, the Lewis dot diagram is very important because it is going to be asked in the exam. So, if there is not question about this part, I am going to ask your permission and I'm going to erase or clean that one because I need the space. All right. So I'm going to clean this side here just in a second. I'll be back with you. Okay, there we go. So let's now answer that question. The Lewis dot diagram. Now, for the Lewis dot diagram, guys, you need to use the valence electron. All right, so let's write that note here. Lewis dot diagram. Now, the Lewis dot diagram, you are going to use the valence electrons. You are going to only use valence electrons. All right, so those are the only electrons involved in a Lewis dot diagram. Are you with me? I hope you, please write the message. That one message is there. All right, now, what are the valence electrons? The valence electrons are the number of electrons in the utmost energy level of that specific element. So it's the number of electrons in the last energy level. All right, now there is a way. We are not going to work with all the elements, guys. We are not going to work with all the elements. There is a way of determining that one. If we, for instance, go here and check the periodic table. Remember, I told you that all the elements in group 1 will have 1 valence electrons. All the elements in group 2 will have 2 valence electrons. You skip the transition metals. Pardon. You are not going to work with those 4 valence. Don't get me wrong. You are not going to use the transition metals or the drawing of Lewis dot diagram. You will use them for other things. Then group 13, which is 3 in Roman number, have 3 valence and so on. So it will be 1, 2, regulations say, and I have to wake up, I don't remember, Lewis structure for something one. But we, as usual, are going to go a little bit better. We're going to do it for more than just one. So in this one is an ionic substance. We're going to skip that one for later on. All right. Now, yes, this one has to do with bonding as well, but it is a little bit complicated because bonding can be covalent, ionic, or metallic. Right. You have to learn how to do the Lewis dot diagram for covalent, for ionic, not for metallic. For metallic, you only need to learn when does it happen, and you need to be able to explain how does it happen. It's quite simple. You can go to the lessons and get that one. I'm not going to explain right now. But covalent, they share electrons. Ionic, they transfer electrons. All right. We have to do it for ammonia, which is a covalent bonding. To identify, you can say that covalent will be non-metal plus non-metal. Non-metal plus non-metal, which is the case here. All right, so we have nitrogen and we have hydrogen. So for nitrogen, you are going to write the symbol nitrogen, and you are going to represent using dots the Lewis dot diagram or the valence electron. Nitrogen, remember, let's go to the periodic table. We love you beautiful children. The periodic table is going to be here. Nitrogen, you can see, is in group 5. So it will have 5 valence electrons. Right? So it's in group 5, it has 5 valence electrons. So it's going to be 1, 2, 3, and 4. You always place one on each side of the element. And then you start repeating. So it's 1, 2, 3, and 4, and 5. Nitrogen has 3 unvalence electrons, 3 unpaired electrons that can be checked. If you go to hydrogen because it's the other atom involved with hydrogen, what is the valence electron for hydrogen? Go to the periodic table. It has 1 valence electron. But how many hydrogens do you have? You have 3 hydrogens. So each hydrogen will share this unveiling of unpaired electrons of nitrogen. In other words, we are going to have the following. Nitrogen with the lone pair. This one is called lone pair. You need to know it. This one here is called lone pair. You don't touch those. You leave those as it is. So then it's coming one here with 1 hydrogen. This one is from nitrogen and the other one is from hydrogen. Check those two. Alright, the other one at the bottom with the other hydrogen and the other one on the left side with the other hydrogen. This one is the Lewis dot diagram for ammonia. That is the one, and it's quite simple. I really hope you understand. Let me just, you are still with me. Oh, the music is still on. Oh my goodness. Oh, I'm sorry. I'm sorry, I didn't know the music is on. Oh my goodness gracious. Hi, guys, what do I have to re-explain? I didn't know that music is on. Okay, let's see. Okay, let's go to the Lewis dot diagram. Okay, I didn't notice when the music started running, and I don't even know why. Maybe I touched a button by accident. Yes, so let's explain again the Lewis dot diagram. Yes, let's explain again the Lewis dot diagram. No problem, guys. From beginning. All right, I'm going to start from beginning. I'm not going to erase it. Let's explain the Lewis dot diagram. I don't know when the music started running. I didn't see, and gee, with nobody was, I didn't see the message. Okay, so it's fine. Now, Lewis dot diagram. In Lewis dot diagram, you are only going to use the valence electrons. That is the first part I said. During Lewis dot diagram, you only are going to use the valence electrons. That's it. The valence electron, by definition, and that is what I'm writing here. This is what I'm writing here. That is the thing with life. Things happen. And I'm alone. I'm solo playing here. The Lewis dot diagram, you use the valence electron, and the valence electrons is the number of electrons in the last energy level. That is the definition. Number of, this is the of, electrons in the last energy level. We'll later on speak more about this one for questions that are coming. All right, up until then. So if you go, then I said, if you go to the periodic table, guys, which is here, the valence electrons is the number of electrons in the last energy level. You can use the Roman number. So all the elements in group 1 will have one valence. All right, using the Roman number. All elements in group 2 will have 2 valence electrons. All right, and so on for group 3, 4, 5, 6, 7, and 8. I am using the Roman number. Okay, so that is important. We are not going to use the transition metals for this work. No, for this work. They be used for something else, not for this work. Okay, so now, before we go there, because there are different ways of doing the Lewis dot diagram, or they could be asked. Bonding, and now we have to bonding. We have 3 types of bond. Covalent, you have to learn the definition. Covalent is the share of electrons. We have ionic. What is ionic? Ionic is when electrons are transferred. Generally, it happens between metals and non-metals. Metals and non-metals. And metallic. I said about metallic, you don't have to do Lewis dot diagram for metallic, but you must be able to explain metallic bonding. So what is it and how it forms? It is in the exam. It is going to be there. It's always there. Now, covalent and ionic, you may do the Lewis dot diagram, and it's differently. In this question, they ask you for ammonia. So let's erase ammonia, because I mean, there was a music that you could not hear, and I didn't notice about that music. And let's redo it. Okay, let's redo it for you all. Let's redo the ammonia. Not a problem, not an issue. Okay, see? Yes. So now we go to ammonia. Ammonia is made of NH3. So it's 1 nitrogen and 3 hydrogen. There we go. 1 nitrogen, 3 hydrogen. So you have to do the Lewis dot diagram for each of the atoms separately. For instance, nitrogen, if you go to the periodic table, and I'm going to show you the periodic table here, it's in group 5 using the Roman number, group 15. It has 5 valence electrons. It has 5 valence electrons, okay? So now, saying that, you are going to place those valence electrons. 1, 2, 3, and 4. You always place 1 on either side of the atom, for instance. Starting from either side. 1, 2, 3, 4, and 5. That is the Lewis dot diagram for nitrogen alone. All right, now I also said, while the music was playing, this that is together is called lone pair. of electrons. That is called lone pair of electrons. You do not touch those. You keep them where they are. They don't move. You keep them there. All right. But now, hydrogen, we have 3 hydrogens. Each hydrogen will have 1 valence. It's in group 1, so it will have 1 valence electron. There are 3 spaces here. You have 3 hydrogens. They are going to share that unpaired electrons. So you will have nitrogen. The lone pair stays there. On this side, you have 1 and the other one for 1 hydrogen. There we go. The other single one of nitrogen and the next hydrogen. There we go. And then the last one there with the other hydrogen. There we go. This one is the Lewis dot diagram for ammonia. I want to know if there is clarity. Okay? So if there is no questions, okay? You talk to me about that Lewis dot diagram. I'm waiting to see if you are clear there, so we can do another one. We can do another one. Okay. That is for ammonia. Let's see there is somebody that it's not clear. Let's do, for instance, oxygen. All right. Oxygen, you have 2 oxygen atoms. You know what? I'm going to erase I need the space. I don't know if that will be enough space. Here. Let's see the oxygen molecule. All right. The Lewis dot diagram for oxygen. We have 2 oxygen. So we have to do the 2 oxygen separated. For instance, oxygen is O. They have 1 oxygen and the other O. There we go. All right. You are going to do the Lewis for each of them. What you have to do, you need to know the valence. The valence electron for oxygen, because we're working with oxygen. What is the valence? If you go to the periodic table, Oh, guys, I don't know what I'm struggling today with the thing. Can you hear me now? Yeah. Can you hear me, Tandy? I'm struggling today with the program. I don't know what is going on. The program is difficult, guys. I'll show you one day the program, how it is too much of buttons here. And then it seems like I struggle today with them. So, yeah. What can you hear me now? Okay. So should I do another example? Okay, let's see. I'm going to erase this part here. All right. Because I already work with that one a lot. Let's do another example. Okay. And let's do a common example. And then we finish. Okay. Common example. Let's do water. It is not part of this one here. But let's do water. H2O. What you have to do? You need to break them. You have oxygen, you have hydrogen. You are going to go for the valence of each of them. All right. Valence of oxygen is 6. Hydrogen, valence is 1. So oxygen is going to be O, 1, 2, 3, and 4, 5, and 6. That is for oxygen. Hydrogen, you have 2 hydrogen. 1, 2. That is hydrogen. All right. So now what is going to happen? You have 2 lone. Remember, do not separate them. These lone pair are together, so you cannot separate them. You keep them where they are. You can move this lone pair to the other side, but must be next to the atom because that is how they are allocated. Okay. So now here, if you combine them, you have oxygen with the lone pair. I'm going to keep them there. That is the lone pair. One of these pair will take 1 hydrogen. The other one will take the other hydrogen. That is now water. The Lewis dot diagram for water. Okay? So that is the Lewis dot diagram for water. I hope it's clear now. I hope it's clear. This water is not in there. It's just one example. Right? Now, if you have a different ionic compound, we're going to see another question. I have the question there for the next stream. All right, but for this one, I think it's right at the time. Let's see quickly. We go here to the question, and I don't touch the thing I should not touch. There. Okay, so we did question 2.4 now. 2.5, identify the type of chemical bond between atoms in substance Y. Now, if we go to substance Y here, substance Y, type of chemical bond, we already spoke about that one. And substance W, we can do all of them. Substance Y, these are 2 nonmetals. So this one is covalent. This is covalent bonding. Covalent bonding. This one here is between lithium, which is a metal, and between nitrogen, which is a non-metal. Therefore, this one is ionic. Ionic bonding. You see? That is ionic bonding. This is hydrogen, it's an element. So these ones will have bonding of covalent bonding. Covalent bonding. And Z is a mixture. So they are not bonding, however, between oxygen, there is covalent, between nitrogen, there is covalent, between hydrogen, there is covalent. Those are all the bonding that possibly can be in that group of atoms. I want to know if there is clear for you guys. Okay? So now we can go to the last part of this question. Just took me longer because I make a mistake there with the sound, and then I'm sorry about that one. Hydrogen gas and nitrogen gas react to produce substance Y. So let's write, we have to write the balance equation. We have to identify between synthesis of decomposition, and we have to calculate or prove the law of conservation of mass. So let's do all that one right now quickly, okay? Let's do all that one real fast. Let me clean here for that question. Let me clean here. Right, so we have to make or write the balance equation for the formation of ammonia. What is that? We have nitrogen plus hydrogen. But guys, nitrogen is a diatomic molecule as well as nitrogen. So this one is going to be H2 plus N2, and that is going to be NH3. All right, if you do that one, even without balancing, you'll get 3 marks. 1, 2. The third mark is going to be for the balancing. So we have to balance. How can we balance this one? We have 2 nitrogens here. We have 2 hydrogen, 3 hydrogen. Let's not fix hydrogen first. Let's fix first nitrogen because I have 2 here. So I can place a 2 at the front. If I place a 2 nitrogen here, 2 nitrogen, I have 2 nitrogen, 2 nitrogen. Hydrogen, I have 2, 2 times 3 is 6, so I can place a 3 here. That is the balance equation for that formation of ammonia. I hope it's clear. I hope it's clear. That was the formation of ammonia. The next question is this decomposition of synthesis. Decomposition is when you break in a compound into elements. In this case, we are forming a compound. That is a chemical change. Chemical changes can be synthesis or decomposition. I'm not going to write it down. Chemical changes can be synthesis or decomposition. All right? Synthesis is when you forming a compound. So that one is synthesis. That is the question then. Is this synthesis or decomposition? So that one is synthesis. You can write it down here. That is synthesis. Why synthesis? Because 2 elements come together to form a compound. All right. And then the final question is to prove the law of conservation of mass. Mass must stay constant. Guys, if it's not constant, it is wrong. The question is wrong. So here you have reactants. This is reactants. So mass of reactants. Here is mass of products. What do you have here? You have 3 hydrogen. Let's write it all plus N2. That is the reactant. The product, you have 3 NH3. All right? That is reactants and products. Let me see if there is any question. I struggle some time to understand. Okay? There we go. So we have to use the periodic table to calculate the mass of everything in here. All right. So hydrogen, you go to the periodic table that you have in the exam, guys, which is this one. You can see the mass for hydrogen is the number at the bottom. It is 1. And then the other one is nitrogen. It is 14. Okay? So that is the one. So we have here 3. This is like mathematics now. 3 bracket 2 times 1 plus 2 times 14. This one is coming from the periodic table. Here you have 3. I'm going to open square bracket. Then is nitrogen, which is 14 plus 3 times 1. And I close square bracket. This is mathematics. You can work separated. Here, let me see if you can see. Okay, you can almost not see that. So this one here is simple math, and this one here is simple math. All right, this one is, let me see, 2 times 1 is 2, times 3 is 6, 28 times. This, let me see. I get 34, guys. (34 grams per mole). Did you get that answer? Let me know if you get that answer. And then for this one here is the same one. It should be 34 grams per mole. There we go. Let me see if it's true. Okay, let me see. There's a mistake here somewhere. Okay, yeah, the mistake is here. It's not 3, it's 2. There we go, there we go. It's 2. It's 2 at the front there, guys. There we go. So the answer, you see, if the answer is not the same, then the question is wrong. The answer must be the same. If it's not the same, the question is wrong. And that is the end of this question. That is the end of this question. That is the end of the question, guys. I don't know. I was planning to go to the next question, but I think the stream took long because of my mistake with the sound and then with the music first and then with the sound. I don't know what was wrong here. I don't know. We can stop and prepare the other one. I wanted to do this question. We can do it later on if you want to, guys. Okay, I'm just cleaning the board while I'm waiting to see what is your answer. Clean the board because I need to draw the graph. So you tell me what you think. You tell me what you think. I'm just going to draw quickly the graph, guys. In the meantime, while I'm waiting, okay, let me see. Okay, it's fine. Then let's continue. So this is the next question, guys, which is also going to be asked in the exam. All right, so I did draw here the graph while I was waiting. This is temperature in Celsius degree. This is time. Time in the question is given in minutes. Time is in minutes. All right. So this is, since the moment you see this graph, you know it's going to be a cooling curve. Temperature decreases. If the temperature decreases, that is a cooling curve. All right. So let's identify the states of matter real fast before we even start answering. This one is gas. This line here is liquid. And this one is solid. Those are the three states of matter and how to know. The states of matter are going to be the lines that are not parallel to the x-axis. So gas, liquid, and solid. All right. Second, these parallel lines are the process of change in state. For instance, from gas to liquid is condensation. That is this line there. That is condensation. This one is from liquid to solid. That is freezing or solidification. All right, this one is freezing. That is freezing. Now, do not confuse this one with boiling point, for instance, or this one with freezing point. It does not work like that. All right, because it is not boiling. This one is not. This one is the freezing point, will be the temperature here. All right, that is this specific question. Do not confuse. This is not freezing point. This is not, how you say, boiling point or things like that. Those are the process that the temperature is constant there. So this is more or less what to understand about this specific graph. So these substances start from gas at 118 degrees Celsius, start to condense. So in this point here, or at this point, at this line, the state is gas and liquid. Gas and liquid. Here, you have a liquid and solid. So every time you have a parallel line, you'll have two states of matter in there at the same time. All right, so let's look for the question now. The question say, define the term melting point in words. I am not going to write the definition. You can go and get the definition. What is the melting point of ethanoic acid? So now, melting point is from, what is the melting point? Let me see if any of you okay? All right. So melting point, guys, melting point is the point or the temperature where the substance melt or is going from solid to liquid. This one is a freezing curve, but they're speaking about melting point. So melting point will be if the graph was on the way there. So the melting point, guys, is going to be 16 degrees Celsius. That is the temperature where a substance melts, all right, or turn from a solid to liquid. That is melting point. It is 16 degrees Celsius. This here is a freezing because it's getting now colder, all right, but the melting point is also there, all right, for that specific substance in here. Let me see what else. Are the forces between particles strong in ethanoic acid or in water? Now you don't have water. You don't have water here, but how will you know that the forces between the particles of where are stronger? Well, the boiling point of ethanoic acid is going to be 118. For water, you know that is 100 degrees Celsius, approximately. The higher the boiling point, the stronger the forces between the substances. You should write that note somewhere. The higher the boiling point, the stronger the forces between the particles. Higher boiling point, stronger forces between particles. You are going to learn about that one in grade 11, about intermolecular forces. For now, you need to know that if the boiling point is higher, that means that the intermolecular forces are, the forces between the particles are stronger. Here you have 118. For water, it's not given to you, but you know it's approximately 100. It means ethanoic acid have a stronger forces between the particles. That is the question here. Let me see what else is in the question. This question is quite simple and it's good for the exams. You know that one is. Here we go. Write down the phase of ethanoic acid at 5 minutes. Now at 5 minutes, let's go to 5 minutes. At 5 minutes is here. You come to the time table, to the time part of the graph. 5 minutes is in between 10 and 0, somewhere there. What is the state of matter? Is guess. We're starting with that part on the question. We identify all the states. All right, we identify all the states there. What else? Write down the name given to the phase change occurring between 10 and 20 minutes. Between 10 and 20 minutes, the phase change is this one here, is condensation. It's condensation. We gave the names to all of them. So it's quite simple, guys. Explain why the change reference in question is a physical change. Okay, all change in phases are physical change. Physical change, remember, changes can be physical or chemical changes. All right, let's maybe write about this one. Right, change in chemistry can be physical change or can be chemical. Physical change, no substance form. Chemical change, new substance form. Change. If it's physical, no new substance is formed. If it's chemical, a new substance will form. For instance, in the previous question, the formation of ammonia is a chemical change because you start with something, two substances, and a new one is formed. This one is a change in a physical state of matter. So it's a physical change. No new substance is formed. Okay? No new substance is formed. We're almost done, guys. Explain why the change is a physical change. In which position A, B, C are the following statement applicable? Forces between the particles are the strongest. This one is grade 8. Strongest in a solid. So C will have the strongest forces between the particles. because it's a solid. All right? And it's a grade 8. The space between the particles is the larger is at guess. So it's A. A have the largest space between the particles because they are gas particles there. And then the last part of the question, the kinetic energy of the particles remains constant. And they give you option of A, B, and C. Kinetic energy have to do with temperature. If the temperature is constant, kinetic energy is constant. So we have 2 points that the kinetic energy is constant, B and this point here. So B, the kinetic energy is constant. Why? Because the temperature is constant. Why is it constant? Because all the energy is needed to form bonds. In this case, is to form bonds or to form forces between the molecules. That is what is happening here. Guys, this is the end of the question. I hope it helped. I'm sorry about, once more, I'm really sorry about the sound. I didn't notice that was running behind, and then by accident, I take the sound off. I'm really sorry, but that is the end of the question. I don't know if there is any question. All right. Okay, so guys, then we're going to stop here, and then later at 3 o'clock, I think I say we're going to the other 2 questions, which are quite important. All right? You can always ask questions, and once more, I'm sorry about the sound and the mute part of the video.